All right, part 2 from the 403 to the HAZ. Mr. Nelson here, I'm a Helu. Okay, hi. So, in the last video, we were talking about linear systems of equations. And a system of equation looks something like this. Minus 4y is equal to 1. And 3x minus 2y is equal to negative 1. Okay, in the previous video, we talked just about what a solution looks like. So we know that these are both equations for lines. Okay, they're not in y is equal to mx plus b form. These are just in, I guess, a general form. But we could convert this to our y is equal to mx plus b form by isolating for y. We can do that. Now, one thing I didn't talk about in the other video was figuring out how many solutions there are. So we know that we have to have as many equations as we do variables in order to solve. So in this case, I have two variables, x and y. X and y, I have two variables. It's not four variables, you don't count them twice. It's just I have two variables. X and y are my variables, and I have two equations. So in this case, my number of variables is smaller or equal to my number of equations. So that means that, yes, I can solve this. Now, how do I know whether I'm going to have zero solutions, no solution at all, one solution, one intersection, or infinite solutions? What would these different scenarios look like? Well, they're all going to be based on what this equation looks like, and specifically what my slope is. So the situation where I have no solutions will be essentially a situation where I have two parallel lines. Okay, so if I have two parallel lines, what does parallel mean? Well, parallel means that they have the exact same slope. So say this slope was 3, well then this will have a slope of 3. These are train tracks. They are always going to be the same distance apart because they have the same slope, but they're not the exact same equation. I will never get an intersection in these lines, which means that I will never have a solution. So when the slopes are the same for the two equations, that means they're parallel lines, and therefore I will never be able to find a solution. The situation where I have one solution occurs when I just have two lines that intersect. So say I have one line like that, and I have another line like this. It could also look like this, where they almost look parallel, but if they're not quite parallel, so say this has a slope of 3, and then let's say this other line has a slope of, 10/3, so just a little bit over 3. Well, you can see that they're almost parallel, but at some point down the road in the future, they are going to intersect. So unless the slopes are exactly the same, they will intersect at some point. And that's kind of my more common situation where I have one solution. Now, what situation would I have an infinite number of solutions? So basically, for every x, the y will be a solution. For every coordinate is a solution. Well, that is essentially, we're going to have infinite solutions when I have exactly the same equations. So say we were given an equation like y is equal to 3x plus 1, or plus 2, and then the other equation of the line is something like y minus 2 equals 3x. Well, if I were to isolate for y in this one, it would give me y is equal to 3x plus 2. These are actually the same equation. So if I were to graph both of these, for example, they would look like one line sitting right on top of the other, which means that no matter where you are on the line, they're going to be intersecting. They're going to be on top of each other. So there's infinite solutions. Okay? And that happens when we have when our two equations in our system are exactly the same equation. It might not look like they're the same, but if you do what I did and isolate, they'll turn out to be the same. So that's how we know how many solutions we can have. A little aside for you. So in the last video, we talked about substitution. Now we're going to do elimination. A method I never used after high school because elimination kind of requires, I think, more idealistic situations, and it's hard to increase complexity with elimination. I think it's just more difficult. That's my opinion. If you like elimination and you can make it work, that's great. Ultimately, choose one of the two methods in the future, and that's just kind of what you roll with. I don't see any purpose in working two methods. It's cold outside today. It's minus 30. That's why I'm wearing my toque and my comfy. So, elimination. Okay. Step one. We'll say stack the equations. Into a subtraction. Okay, so what does that mean? Well, it just means turn it into a subtraction. So if I have 3x minus 4y is equal to 1, now I'm going to add a subtract, and I'm going to subtract the other one. Minus 3x minus 2y is equal to 1. Step 1 is stack them. Step 2 is if you can subtract the equations to get rid of a variable, go for it. The steps in elimination are not as clear-cut, but it's a little bit more of a process. What does this mean? Okay, what I'm trying to do in elimination is subtract one equation from the other to get completely rid of one of my variables, my x or my y. In this case, if I subtracted these two equations, 3x minus 3x, and negative 4y minus negative 2y, 1 minus negative 1, will I get rid of a variable? Yes. 3x minus 3x will leave me with 0x. That is what I want. I want to get rid of one of my variables so that I have 0 when the subtraction is done. Now I can do negative 4y minus negative 2, which is the same as negative 4y plus 2 is negative 2y. Negative 4 plus 2 is negative 2y. 1 minus negative 1 is the same as 1 plus 1 is 2. Now I have, if I get rid of this altogether, I have negative 2y is equal to 2, and if I solve for y by dividing negative 2, I get y is equal to negative 1. Now, I can use substitution. Funny, I have to use substitution and elimination. Now I can take this negative 1 and plug it back into one of my two equations and then solve for x. So let's say I use this one. Okay, so 3x minus 4y, but y is negative 1, is equal to 1. And then I get 3x plus 4 is equal to 1. 3x is equal, I'm going to subtract negative 4. 3x is equal to negative 3, divide by 3, divide by 3. X is equal to negative 1. So in this case, these two equations have a solution at negative 1, negative 1. That is where they intersect. At x is equal to negative 1, y is equal to negative 1. So this is the ideal situation where when we do the subtraction right off the bat, it works out that we get rid of a variable. However, it's not always going to be like that. So let's try one where it's not so straightforward. Comme ça. So let's try, let's see if I got one here. Let's see if, say I had 3m minus 6n is equal to 0, and 9m plus 3n is equal to negative 7. Okay, so I'm going to stack the equations. I'm going to follow step 1, so let's stack them. 3m minus 6n is equal to 0. With the subtraction, 9m plus 3n is equal to negative 7. Okay, so if you can subtract the equations to get rid of a variable, go for it. Can I do it? So if I subtracted 3 minus 9, I'm going to get negative 6m. That's still there. That variable still exists. Negative 6 minus 3 gives me negative 9. So if I just go ahead and subtract, I'm not going to get rid of one of my variables. So now the third step then is, if not, multiply one or both, could be both, equations by a factor that will lead to getting rid of a variable in the subtraction. So what does that mean? Well, I want to multiply one of these equations, or both. In this case, I only probably need to do one. I'm going to multiply one of these equations by a factor so that the subtraction works out. So let's say I want to get rid of m's. What do I have to multiply this top equation by in order to be able to subtract out m? Well, it needs to be 9, because 9 minus 9 will make 0. So I'm going to multiply the whole equation, because I have to do, what do I do to one side of the equal sign, I have to do to the other. So I'm going to multiply the whole thing by 3. And then this will give me 9m minus 18n is equal to 0. And then I subtract 9m plus 3n is equal to negative 7. So 9 minus 9, 0. Bingo. Negative 18 minus 3 is negative 21 is equal to negative 7. So negative 21n is equal to negative 7. Divide by negative 21, divide by negative 21. N is equal to 7 over 21, which is the same as 1/3. 7 goes into 21 3 times, 1/3. Okay, n is 1/3. Now I can take this n in my little sub into other. Okay, so I'm going to take this n is equal to 1/3, and I'm going to sub it back into one of these equations. Let's sub it back into this one. So I get 9m plus 3 times n, and n is 1/3, is equal to negative 7. 9m, 3 cancels out with 3. 3 times 1 divided by 3 is 1, plus 1 is equal to negative 7. 9m is equal to negative 8. So m is equal to negative 8 over 9 if I divide by 9. So my intersection in this system occurs at m is equal to negative 8/9, and n is equal to 1/3. That is my intersection. That is my solution. Okay? Hopefully this doesn't seem too crazy scary. Let's try one more, even more difficult situation, and then you need to just go through and practice these yourself. I cannot jam math knowledge into your brain. You have to, just like if you were to learn karate, you have to do reps. You gotta, if you want to learn how to box, you gotta throw some jabs. A lot of jabs. You gotta be like Money Team. Like Mayweather, baby. Mayweather just puts in work. Hard work. Okay. Hard work. So let's try an even more difficult situation. Here we go. This one's lovely. We did this one substitution style. Now we'll try it elimination style. 2a plus 3b is equal to 0. Okay? So I'm going to go through my steps for elimination. I'm going to stack the equations into a subtraction. So 3a plus 2b is equal to 5. Subtract 2a plus 3b is equal to 0. If you can subtract the equations to get rid of a variable, go for it. Can I? 3 minus 2? No. 2 minus 3, that's not going to get rid of. So if not, multiply one or both equations by a factor that will lead to getting rid of a variable. So this is what I was talking about before. Now let's look at this. If I multiply this equation by 2, this will give me 6a plus 4b. But I can't subtract that. I'm going to have to multiply both of these equations by different factors to get them to a point where I can actually subtract them. So let's see what that would look like. And this might be a little guessing test. So if I multiply the top one by 2, this will give me 6a and 4b. What do I have to have down here in order for the a's to disappear or for the b's to disappear? Well, let's try and get rid of the a's. So if I want to get rid of the a's, so minus, I'm going to have 6a down here. How do I get 6a down there? Well, I have to multiply this one by 3. So I'm multiplying the top one by 2 and the bottom one by 3. And that will give me 6a plus 4b is equal to 10. 2 times 5 is 10. Then I'm subtracting 6a plus 9b is equal to 0. Now I go through and I do the subtraction. I get 0a. Perfect. 4 minus 9 is negative 5b. 10 minus 0 is 10. So I have negative 5b is equal to 10. Divide by negative 5. Divide by negative 5. b is equal to negative 2. Beautiful. Now I take that negative 2 and I sub it back into one of my equations to solve for a. So let's do this one. So I get 2a plus 3 times b, which is negative 2, is equal to 0. 2a minus 6 is equal to 0. Add 6 on either side to get rid of the 6. 2a is equal to 6 divided by 2 divided by 2. A is equal to 3. So my intersection happens at a is equal to 3, b is equal to negative 2. And that's as difficult-ish a elimination problem as you'll get. So, thank you for watching. That is substitution and elimination. Well, today's elimination. Bye.